This video is for the Unit 2 review, Part 1. So the distance d in meters traveled by a skateboard on a ramp is related to the time traveled t in seconds. This is modeled by the function d of t equals 4.9 t squared minus 2.3 t plus 5. What is the maximum distance the skateboard can travel, and at what time would it achieve this distance? So first we need to know, what is this question asking us? It's asking what is the maximum distance the skateboard can travel and at what time can we achieve this distance. Okay, some important things we need to know is that our distance is d, distance, and this is in meters. We also need to know our time is t, and this is in seconds. So if we're wanting to know what the maximum distance is, that would refer to our maximum, which also refers to our vertex. So we need to know the vertex. Well, if we're traveling distance, that's going to be our y value of the vertex. So y value of vertex. If we're doing time, that's going to end up being our x value of our vertex. So in order to find my x value of my vertex or my time, I'm going to do x equals, or really t equals, in our little formula to find the x value, negative b over 2a. So I plug in my values. I have a negative, and I'm plugging in a negative 2.3. And I divide it by 2 times 4.9. Two negatives make a positive, so I get a positive 2.3 over 9.8. When I plug that into my calculator and I round to the nearest hundredth, 2 decimal places, I get about 0.23. So about, and this would be how long it took to travel the maximum distance. So this would be my time, so equals my t. Now, in order to find my y value or my distance, I need to plug it back in. So I have d of 0.23 equals 4.9 times 0.23 squared minus 2.3 times 0.23 plus 5. So make sure you do order of operations on this. So if I were to type this all on my calculator, I get, rounding to 2 decimal places again, about 4.73. Okay, and this would be my distance, so my d. So I would travel a maximum distance of 4.73 meters in 0.23 seconds. So this is the answer I'm looking for. Moving on to question number 2. Selena is standing on a rock cliff that is 52 feet high. She tosses a pebble over the edge where it hits the top of a 12-foot high boulder. The quadratic function that models the height in feet of the pebble after t seconds is h of t equals negative 16t squared plus 12t plus 52. How long did it take the pebble to hit the top of the boulder? So again, our important question, how long did it take? So we're looking for the time. And remember, it said time was modeled by t. So I'm not looking for the same thing I did in the last question. I'm looking for how long did it take, meaning when did it hit the ground again. So I'm looking for the x-intercepts where it crosses the x-axis. So what I'm going to do for this question is I'm going to use the quadratic formula to help me figure it out. So first, I have it where everything's on one side. I'm going to label my a as negative 16, my b as 12, and my c as 52. I'm going to go ahead and plug it into my discriminant formula. That formula is b squared minus 4ac. It helps break up the quadratic formula. That's why I like to do it first. So I have 12 squared minus 4 times a negative 16 times 52. When I plug that into the calculator, I get 3,472. This is my discriminant value, meaning I should have two real solutions. So two real solutions, which if I'm talking about time, it better be real. Two real solutions. And that's just stuff to help me. We don't have to do this. Okay, so my quadratic formula is x, or t, equals negative b plus or minus the square root of b squared minus 4ac. Start singing a song. All over 2a. So here I plug and chug. So my b was 12, so I have a negative 12 plus the square root of 3,472 all over 2 times a negative 16. So I'm going to start simplifying stuff. So I get a negative 12 plus or minus, and I'm going to actually take the square root of it this time because we're talking about time. I actually want to know the value, and I'm going to round to 2 decimal places. So I get 58.92, and then 2 times a negative 16 is a negative 32. So what I need to do is I need to break it up and see what, I'm going to say t, when negative 12 plus 58.92 divided by negative 32 equals, but I also need to know negative 12 minus 58.92 divided by a negative 32 equals. Okay, so when I plug it in and I use my calculator for this first one, I get t equals a negative 1.47, and the second one I get t equals 2.22. Well, if we look and we think about time, we cannot have negative time, so this answer goes away. Again, we cannot have negative time. That's why we don't want that answer. We do not want negative time. So it took me 2.22 seconds for the rock to hit the top of the boulder. So 2.2 seconds. Make sure we label it. And this is my answer. So again, we ignore the negative one because we don't have negative time. So it took us 2.22 seconds to throw a rock and hit the boulder. Moving on to question number 3. It says find the zeros of this function. So you can do this by quadratic formula. You can do it by completing the square, or you can do it by factoring. In this case, I am going to do it by factoring. Okay, again, completing the square and quadratic formula will get you the same answers. So I'm going to do the x, and I'm going to do the box. So the top of the x, I multiply first times the last, so I get a negative 24x squared. I get a negative 2x here. So I have to think, what can I multiply to get a negative 24, add to get negative 2? That'd be a negative 6x and a positive 4x. So I get x squared, negative 24, negative 6x, 4x. So I got x times what gives me a negative 6x. I get a negative 6. X times what gives me 4x. Gives me a positive 4. So my factors for this is x minus 6 times x plus 4. And then I need to set it equal to 0 to actually solve it because it wants to solve for the zeros. So I split it up and I set each factor equal to 0. Again, each factor equal to 0. And I add 6 here, add 6. I get x equals a positive 6. So there's 1 0, minus 4 minus 4. I get x equals negative 4. Again, if you complete the square or quadratic formula, you will get the same answer. Number 4 says find the min or max value, keyword value, of f of x equals x squared minus x plus 10. Then state the domain and the range of the function. The domain and the range of the function. So to first find the min or max value, that is, so min or max value is the y value of the vertex. It's that highest or the lowest point. So in order to do that, first I have to find the x value of the vertex. So I get x equals negative b over 2a. I have a negative, and then my b is a negative 1 all over 2 times a positive 1. 2 negatives make a positive. 2 times 1 is 2. 0.5. The only reason I'm changing it to a decimal in this video is because it just makes it easier on us to type in the calculator. So now I need to find f of 0.5. So I do 0.5 squared minus 0.5 plus 10. When I type that into my handy dandy calculator, I get 9.75. Okay, so my max value is 9.75. Now I need to know my domain and my range. Well, remember, my domain is always all real numbers. Okay, my range goes bottom to top. So what I'm going to do is I'm going to help draw a photo. Okay, so the photo is going to look like this. This is my 9.75. This is my vertex, so I'm going to go ahead and put 0.5 with it. So notice all my y values are going up. So every y value is getting bigger than or equal to, so greater than or equal to 9.75. And this is everything I need to know for the question. I have my max value, my domain, and my range. Okay. Number 5 says using f of x equals x squared as a guide, describe the transformations that yield f of x equals 7 times x plus 3 squared minus 1. Yield just means what transformations take place. It's just a fancy word they want to use. So remember, the 7 is in my A spot. So I have a vertical, Okay, I have a vertical, my pen's not wanting to work now. There we go, vertical stretch of 7 because A is greater than 1. So vertical stretch of 7. Go ahead and write that there. I have x plus 3. Remember, we think opposite of this one. Okay, again, opposite. So I'm going to move, I would think it goes in the positive direction, but it really goes in the negative direction. So it's going to move to the left 3 units. And it goes down 1 unit. And that are all the transformations that yield this equation. Okay, looking at number 6, it says simplify, and I'm multiplying. So when I multiply, remember this is where I use the box to help me, or you can FOIL. I get the same thing. So I have 11 minus 4i, negative 5 minus 9i. I'm just going to multiply to fill in the boxes. So I get a negative 55, get a negative 99i. I get a positive 20i and a positive 36i squared. Remember, I squared equals negative 1, so I get 36 times negative 1, which gives me a negative 36. From here, I just combine like terms. So negative 55 and a negative 36 give me a negative 91. And then 20i minus 99i give me a negative 79i. And that is it. When it comes to simplifying, all I had to do is multiply because I did not see a plus sign, I did not see a minus sign in between the two sets of parentheses, so that means I'm multiplying. Moving on to question number 7. Okay, it says use the quadratic formula to solve. So I'm going to use my quadratic formula. So I start by saying a equals 1, b equals negative 4, and c equals 18. If I notice, everything's on one side of the equal sign. So I'm going to find my discriminant first. So I'm going to use my b squared minus 4ac. Okay, so I have a negative 4 squared. Make sure that goes in parentheses. Minus 4 times 1 times 18. When I type that into my calculator, I get a negative 56, which means I should have 2 non-real solutions. Okay, it's non-real because, the discriminant's negative, so therefore I should have an I in my answer. So now I can go to my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I plug and chug. X equals negative, and my b value is a negative 4, plus or minus the square root, I already figured this one out, was a negative 52, all over 2 times 1. 2 negatives make a positive, so I have 4 plus or minus. Now I need to simplify the radical, so I look for the biggest perfect square that goes into 56. That would be 4. So the square root of 4 is 2. The square root of negative 1 is I. And what's left over is 14. And then 2 times 1 is 2. Now I can simplify everything that is not under the radical. So I can simplify the 4, the 2i, and the 2. Okay, so 4 divided by 2 is 2. So I get x equals 2. 2i divided by 2 is 1. So plus or minus just a 1i or I. Rad 14. And there you go, I solved it using the quadratic formula. Number 8 says write the quadratic function c of x equals x squared plus 6x plus 14 in vertex form. So I don't like that c of x, so I'm just going to go ahead and change it to a 0 and rewrite everything else. I need to make sure my c term gets moved to the other side. There is a way to do this where we do not move it to the other side, but I just like to keep everything the same, and then we'll just move it back over at the end. So now I need to add my spaces. Okay, so then I half my b term, so negative 6 divided by 2, I get a negative 3, and then I square that. Okay, so negative 3 squared equals a positive 9, so 9 goes here, 9 goes there. So remember my shortcut, I have my variable and my half term squared, and it equals my squared term and my c term added, so negative 14. Negative 14 plus 9, I get a negative 5. And if I want to write in vertex form, everything has to be on one side, so I'm just going to add that 5 back over just to, help me out. So I get 0 equals x minus 3 squared plus 5. And then I need to go ahead and use c of x. So c of x is going to replace the 0. I get x minus 3 squared plus 5. So there is my quadratic function in vertex form. Okay, moving on. Number 9 says simplify. We have 21 minus 16i divided by I to the third power. So before we even start, we need to simplify that I to the third power. So remember, I to the third power equals negative I. So I'm going to rewrite this and replace this I to the third with negative I. So I get 21 minus 16i divided by negative I. So remember, we do not like i's in the denominator, so I need to multiply by the conjugate of the denominator, which means I change the sign of the imaginary part of my denominator. So I'm going to multiply everything by a positive I. Okay, so in this case, I'm just going to use the distributive property instead of trying to draw the boxes out. You can draw the boxes as the same thing. So I'm going to distribute. So I times 21 is 21i. I times a negative 16i is a negative 16i squared. But remember, I squared equals, so negative 16i squared equals a negative 1. Negative 16 times negative 1 is a positive 16. So I get 21i plus 16, but we want it in a plus bi form. So we're going to rewrite it as 16 plus 21i. Oh, 21i, there we go. Okay, so there's my numerator. Now my denominator was negative I times I. Oh, can't write today. Times I, which gives me a negative, and let's just think there's a 1 there. Gives me a negative 1i squared. Remember, I squared equals negative 1, so I get negative 1 times negative 1, which is a positive 1. Okay, So I get all of that over 1, and when I simplify it, I don't need that 1 in the denominator. So I get 16 plus 21i. Okay, looking at number 10, this is one that could be a bonus question on the test. It says, write the quadratic function in standard form with zeros of -9 and -12. So this just means we're working backwards. So we know x equals -9, x equals up -12. So I'm going to work backwards. I'm going to put the 9 on the other side. So I get x plus 9. I'm going to add the 12 to the other side. So I get x plus 12. And now that I have it in factored form, I'm going to multiply it out to put it in standard form because that's what it wants, standard form. So I'm going to FOIL. I'm actually going to use the box because I prefer the box method. So I get x plus 9, x plus 12. So x times x is x squared, x times 12 is 12x, x times 9 is 9x, and 9 times 12 is 108. So now I just combine my like terms, which are my 9x and my 12x. So I get x squared plus 21x plus 108. And this is my function with the zeros at -9 and 12, and it's written in standard form. Okay, moving on. Number 11 says, for the quadratic equation with the discriminant 7 squared minus 4 times 5 times 3, identify the number of solutions and their types. So we want to know, is there one solution, two solutions? Are they real? Are they complex? That's what we're trying to figure out. So 7 squared is 49. -4 times 5 is a -20. -20 times 3 is a -60. 49 minus 60 gives me a -11, which means they have two complex, that's the wording they will use on the quiz tomorrow, complex solutions, which is the same thing as non-real. Okay, so remember, if our discriminant, so if b squared minus 4ac is greater than 0, meaning it's positive, we have two real solutions. If b squared minus 4ac equals 0, we have one real. And lastly, if b squared minus 4ac is less than 0, we have two complex or non-real solutions. These are the only three options we have. Now it says use the description to write the quadratic formula in vertex form. The parent function of f of x squared is vertically stretched by a factor of 2, translated to the 14 units to the right and up 6 units. So what I need to know is I have my new function, so I'm just going to say g of x. It can be whatever you want it to call. So vertex form is a times x minus h. It's squared plus k. So it says it is vertically stretched by a factor of 2. Okay, so because it's vertically stretched, that means it's my a value. So 2. And then it's translated 6 units to the right. So remember, if it's going in the right, it's in the positive direction, but it looks negative in my equation. And then up 6, so put plus 6 for the k. And there's my new function. Okay, number 13. It says simplify. We have I to the 9th power times the square root of a -289. Well, first off, we need to know what I to the 9th is. So let's go ahead and simplify that. I to the 9th. I take my 9 divided by 4. Okay, 9 divided by 4. And I'm looking for the decimal that I get for it. So 9 divided by 4. My decimal is 0.25. Okay, meaning that I to the 9th equals I. So I'm going to rewrite it. I times the square root of a negative 289. Well, 289 is a perfect square, so I know I times 289 is 17, and then since there's a negative under the radical, I get an I, so I need to multiply it. I get 17 times I squared. Well, remember, I squared is a negative 1, so I get a negative 17 as my answer. Number 14, it says, consider h of x equals negative x squared plus 8x plus 15. Identify its vertex. So I'm going to label A equals a negative 1, B equals 8, and C equals 15. I get x equals a negative b over 2a. I plug and chug. Negative 8 plugged in. 2 times a negative 1, negative 8 divided by a negative 2. And my answer, I get a positive 4 when I divide. That's my x value of my vertex. To find my y value, I plug it in. Please be careful when you do this because it's a negative, but I'm plugging in a 4 for x. Plus 8 times 4 plus 15. So 4 squared is 16 plus 8 times 4 is 32 plus 15. Okay, a negative times 16, so I get negative 16 plus 32 plus 15. And when I add those all together, I get 31. So my vertex is 4, 31. Yes, your vertex can be a big number. It's not going to hurt you. Last question for the part 1 says to solve 36x squared plus 25 equals 0. I'm going to show you 2 different ways on how to solve this. Okay. So the first way we're going to do the quadratic formula because that always works. But we're missing that b term, so I'm going to go ahead and rewrite it to show that I'm missing the b term. So my a equals 36, my b equals 0, and my c equals 25. So I get b squared minus 4ac. I get 0 squared minus 4 times 36 times 25. When I type that into my calculator, I get a negative 36,000. So I go straight to my quadratic formula. I get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I plug and chug. So negative, I'm plugging in a 0 plus or minus the square root of negative 36,000 all over 2a. And remember, since that discriminant was the negative 36,000, I should have 2 non-real solutions, meaning I will have i's in my answer. Oh, instead of a, I should have plugged in 36. There we go. So let's start simplifying it. Well, negative 0, that doesn't make a difference, so we're going to have x equals 0 plus or minus the square root of a negative 36,000, or not 36,000, sorry, 3,600 is 60i because it's negative, and then 2 times 36 is 72. Well, if I add or subtract 0, it's just going to be plus or minus, so I'm going to have plus or minus 60 over 72i. I need to simplify that fraction. Okay, 12 goes into both numbers. So I'm going to simplify everything by 12. So I get x equals plus or minus 5 over 6i. This is my solution. Okay, you also could do this another way. So I'm going to draw a line down the middle, and I'm going to show you how I would solve it. So 36x squared plus 25 equals 0. Since I'm missing the b term, it makes it a little easier to solve this. So what I'm going to do is I'm going to minus 25 from both sides. So I get 36x squared equals a negative 25. I'm going to divide both sides by 36. And this only works because I don't have the b term. So I get x squared equals a negative 25 over 36. Then I'm going to take the square root of both sides. So remember, the radical cancels out the exponent. Well, the square root of 25 is 5. The square root of 36 is 6. Square root of negative 1 is I. So when I take the square root of a negative 25 over 36, I get plus or minus 5 over 6i. So again, it's your personal preference. Quadratic formula always works, but this is how I would solve it if I saw this equation. So this is the Unit 2 review for Part 1 of the test. Unit 2 review for Part 2 will be coming soon.